Dr. Zhang. Our group is miniaturization and its effect on ISM. I'm Robert. We have Glenn here, Jack, and Braden as well. To start off, I'll talk about our overview of miniaturization and its effect on information systems. I include some bullet points here. Miniaturization is the trend to create even smaller technological objects and components over time. It's been around for about 50 years and continues to gain steam in today's world. I guess kind of a unique fact about it is IBM and a worker for IBM, Robert Denard, are credited with beginning the trend of miniaturization in 1974. This was when Denard recognized MOSFET technology, which I'll kind of talk about here in a minute, scaling and miniaturization. So here's a description for that. MOSFET scaling is the reduction in the parameters like current voltage, electric field, due to reduction in length of the transistor with the advancement in technology. So it's like in this picture here, you can see it's the components of the electrical piece right here getting smaller over a period of time. Brief history and timeline of development. Denard and his colleagues conceived the scaling theory, a concept of reducing dimensions of metal oxide field affect transistors, MOSFET, and their in connecting wires, which led to a denser, less expensive, and faster integrated circuits whose property grew directly proportional to the degree of miniaturization. He published a paper on this called The Design of Ion Implanted MOSFET with Very Small Physical Dimensions. It is now a classical paper and is recognized by the Proceedings of the Institute of Electrical and Electrical Engineers in 1999. So needless to say, it's very prominent. And this theory is kind of what drives any technological miniaturization item that you see out in public today, whether it's your modern phone. If you think about the big phones that were around in the 70s and 80s, I have a picture later on that kind of goes and talks about that. But think about the big phones to the iPhones we have now, and that's just kind of one example of miniaturization and its change over history. And we kind of discussed Moore's law in class too, and I think you have to talk about Moore's law when you're talking about miniaturization. Moore's law is the idea that the number of transistors on an integrated circuit can be doubled every 18 months. So as the item is getting smaller, the power of the item is actually increasing. This graph right here kind of depicts that. And relevant IT components. Proper and efficient miniaturization in electronic devices is often seen through fitting more transistor nodes on a smaller IC. The IC is integrated within its intended system or device so that once assembled, the system can carry out the desired function. The technology is made thinner yet mightier. That goes back to what I talked about on the last slide. There's multiple different techniques to get this accomplished. We'll talk about three right here. There's the ball grid arrays, which is currently very common. It's limited in its ability to reduce in size though, and you'll see that in the pictures on the next couple slides. And then there's the wafer level chip scale packages, which is versatile but challenging to assemble, and it is the smallest currently available option. And then there's the chip on board, which is sometimes seen as the way of the future and allows for integration, but it is difficult design to get right, obviously, because of the integration factor. Here's a picture of the ball grid array technology. I'll mention in the first sentence, it talks about strategic designs that enable large amounts of connections between the integrated circuit and printed circuit board. So you can see all the connections that are located around here. This increase in connection enhances the ability to route signals and therefore increases the processing power of the system it is being assembled into. This is the wafer level chip scale package technology. I mentioned earlier, it's essentially micro scale IC mass created on a wafer that are later diced into an individual IC containing die or chips of a few millimeters in length and width. This picture here kind of just gives a perfect example of what that is and how often you'll see it in the field. Chip on board is simply a specialized process for attaching integrated circuit chips to any given substrate or board. So that goes back to what I talked about on a couple slides ago with integration. It's kind of the chip used for integration of ICs. It's wide variety of technological devices being developed. The size and shapes of both IC and the substrate vary drastically by product. So kind of, again, allows for more integration.
So getting into the relevant cost section of the project, I want to talk about the relevant cost of miniaturization. So one of the main things that is a huge cost is the expensive technologies that are needed to be produced. Sometimes miniaturization isn't always the best, although it could be good. Sometimes it's better to just have the full size product because miniaturization could be very expensive. Also, another relevant cost would be the increased time and effort that it costs workers. Miniaturization takes a long time. It's not something that can just be done quickly. It typically takes longer than just making the full size product. So that's something that could also hinder a company. Another thing is the loss of product features. This goes in scale with things such as how customers would buy it. For example, an iPhone, if they miniaturized it, you might be missing out on many features that people like within the iPhone, which could therefore cause people to not want to buy it as much and could cause them to pick a competitor. So that's something that you could be missing out on. That's a huge opportunity cost that you're losing out on by doing that. Um, Also, the device is reduced to the point where it may not be able to perform its intended function. Like that goes back to my last point, detailing product features. Sometimes you might not get what you want from your device because the device is miniaturized, meaning that you may not get the exact thing that you want, but they might give another thing, but you might want that specific thing. So therefore it could be very hard to sell the product. Another thing is typically miniaturization causes a lack of user interface. This basically means that different users have different needs. And with miniaturization, that makes it kind of hard for the users to get the needs that they want. And therefore it could be very hard for you to sell a product that's miniaturized. Um, Another major thing that I was seeing was that they said it was an increased cost of applied power. Applied power is very expensive, so you don't want to have too much of it because it can run your company's expenses through the roof, and that's not something you want. Every company wants to save money, so they definitely don't want a lot of applied power. And with miniaturization, it's going to take a whole lot of that. So that's something that would make a company want to run away from miniaturizing their products. And lastly, a major thing is the higher temperature for individual components. The main point I want to stress here is overheating. Now, typically with iPhones on a day-to-day, if they're in the sun for too long, they might start overheating and they might cut off. Well, the main thing with miniaturization is that sometimes it doesn't even have to be the sun. It doesn't even have to be an element that makes the product overheat. Sometimes with miniaturization, things could just heat up and all of a sudden the device could stop working or it cannot function the way that you would want it to. So that's something that would really be stressful to a customer. And I know that's something for sure that a customer wouldn't want. So all of these relevant costs are a huge, they're huge in raising the amount of money that you have as a company. And that's why you definitely have to watch out for these relevant costs.
So I'm going to be talking about the relative benefits of miniaturization and then followed by some current applications and limitations of this trend. So the bigger is better phrase is an often repeated business buzzword in the 2000s that is closely coming to an end with the entrance of miniaturization. And across many industries, the trend in recent years has been all about miniaturization, the manufacturing of even smaller mechanical, optical, medical, and electronic products and devices. So you can take the electronics industry as an example. The size of the microchips has grown smaller, and as a result, everything related to it in the supply chain has adjusted to accommodate the new compact size. Computers are another perfect example of the endless progress and possibilities of miniaturization. While parts have grown smaller, advantages have increased. They're lighter, occupy less space, consume less energy, and the list can go on and on. The benefits of miniaturization can, for example, also free up space to allow for the incorporation of larger batteries without increasing the overall size of the device. This makes it easier for designers to deliver longer battery life between charges, something which appeals to consumers in almost every business sector. Michael Casey, head of the extrusion applications and design at Minilex, who I'll be talking about later, explains that just because something gets smaller does not change the expectation of performance. If anything, there's a presumption of improved performance. Precision in manufacturing then becomes of greater importance, which I'll be talking about in the limitations section of my presentation. Some current applications, and we're going to kind of dive into what Minilex does. The Minilex Corporation is family owned and founded more than 50 years ago. They have been at the forefront of manufacturing high tolerance, small profile, custom aluminum extrusions. And I'll get to what that means in a second. But product miniaturization demands innovative manufacturing technologies and techniques. So the rise in demand for these technologies that Minilex is producing is exceeding demand. And so the inherent properties which they produce in aluminum is light, durable, and rust-proof, which is far better than what is used currently, which is plastic. And it is not highly moldable with these component parts. And so aluminum is a great option. And so some current application that Minilex impacts in many different industries is the lighting industry. The lighting industry recognizes the advantages of miniaturization. And so LEDs for displays under counter lighting are now pretty small in size versus much larger channels fixed with traditional bulbs. And so these LED strips Minilex uses to offer strips that house those small little LED bulbs. In the aerospace world, satellites are obviously shrinking in size. And so that means the parts being developed are more intricate and have to maintain a core functionality. So as satellites electronics get smaller, the cooling systems also have to shrink in size. And so what Minilex does is they provide custom aluminum extrusions to hold those cooling systems to operate. In the medical sector, there has been a measured shift in size reduction within surgical and medical applications to support minimal or non-invasive surgeries. And so Minilex produces aluminum extruded rods for use with or in tandem with a bone saw. And so it's basically a thin piece of spaghetti, and it's precisely crafted for durability and optimum performance throughout the life cycle of the device. In the electronic sector, the dimensions of handheld scanners have dramatically diminished in size in recent years, almost doubling, or actually just reducing in size by almost double. And so what started out as a rather large and bulky device is today produced at less than half the size as mentioned. And so Minilex creates the interior extrusions that secure a scanner's electronic components. And so when the company started originally producing them, the scanners were more than double the size than they are now. However, at even roughly half of previous size, there is, similar to many other electronic devices, every indication of outstanding performance, regardless of the size. And so some limitations, as mentioned previously, there's really no room for error with miniaturization when producing a product, considering its small size. It has to be arrow point precise, and then any errors could lead to increased manufacturing costs, which will obviously raise production, as seen in that image right there. And then also it will increase scrapping of the product, which decreases efficiency levels for the business. Also, that leads me into my second point, that the effect that miniaturization has on products can only go so far. Like, you can only make a product so small so that it offers the ideal benefit.
Next, we'll cover some of the relevant risks of miniaturization technologies and their component parts. Risks include the potential increased costs and difficulty of producing ever smaller technological devices, threats from adversaries and bad actors due to miniaturization, design risks in the human application, environmental and economic consequences of our reliance on miniaturization. Advancements in nanotechnology have established a new frontier of technological capability. However, Costs and difficulty of scaling down devices is becoming a greater challenge as Moore's law reaches its technological and physical limits regarding heat and power based on existing technologies. Simply put, smaller parts, components like more efficient and powerful nanometer chips come with greater challenges. Designing, developing, and manufacturing these miniaturized technologies requires more advanced and expensive equipment, and of course, novel approaches to achieve innovative solutions. Threats from bad actors are another significant risk of miniaturization. In recent years, North Korea's leader, Kim Jong-un, announced its country was able to miniaturize, lighten, and standardize nuclear weapons and to make them tactical ones. So we see a picture of some of the nuclear testing, some of the rockets that they've fired off, and it's obviously a significant threat to us. So threats like these are made possible by miniaturization, present challenges to global security as North Korea and other hostile actors harness these technological capabilities. Design risks are yet another challenge as the boundaries of human application are pushed to unprecedented levels. Without careful research and design, considering end users and user environments, miniaturized devices may fall short of their promise in terms of adoption and application. Next, we'll discuss economic risks. Reliance on higher performing and more efficient chips is a double-edged sword, especially with only a few manufacturers like Taiwan Semiconductor Manufacturing, or TSMC, supplying tech industries. So TSMC supplies almost all of the world's most sophisticated chips. Of course, during the COVID-19 pandemic, high demand and low supply, compounded by a supply chain breakdown, led to a global chip shortage. This chip shortage impacted many industries and drove up consumer prices and delivery cycle time for goods like cars, laptops and tablets, gaming consoles, home appliances, and more. The process of mining, manufacturing, and shipping component parts for chips has risks to the environment as well. Mining operations for metals used in production of transistors and chips can have detrimental costs to the surrounding and global environments. Shipping also has significant contributions to greenhouse gas emissions. Companies producing technological devices that don't choose properly certified disposal partners, which we discussed in class, can obviously lead to products landing in toxic e-waste sites. So for future trends of miniaturization will be discussed using the application of nanotechnology and microchips, which is possibly the most significant driver of miniaturization in the future. Future trends of miniaturization are nearly boundless. Trends discussed will include medical, aerospace, energy and environmental, electronics, and consumer market fields. In the medical field, miniaturization is making more personalized, cheaper, accessible, and effective care possible. Devices like the stationary MRI machines, which are ridiculously expensive and require patients to be inside them. I'm sure many of us have used them before. They're huge. They're being downsized significantly with the introduction of cheaper and movable, hyperfine swoop portable MRI machine, which you see there on the bottom right of your screen. Within the aerospace industry, the application of nanoparticle materials and processes will make travel in the skies and space safer, cheaper, and more sustainable. Everything from reductions in aircraft and spacecraft weight to increases in fuel efficiency will be driven by miniaturization. Future trends will also extend to the energy sector and the environment. Again, applications of nanotechnology will lead to improvements in fuel efficiency, as well as renewable energy sources like solar and wind. In transportation, advancements in nanotechnology will produce lighter, safer, smarter, and more efficient vehicles, aircraft, spacecraft, and chips, so pretty much all forms of transportation. Everything from better tires, self-repairing structures, to high efficiency, low-cost sensors and electronics will lead to improved and more sustainable travel. The electronics industry will benefit greatly from further miniaturization with trends like greater flash memory for smartphones and thumb drives, bendable electronics, to yet packing more transistors onto a microchip. Finally, goods in the consumer market will be transformed with further applications of miniaturization through nanotechnology. Imagine smart fabrics that have embedded health monitoring and can capture solar energy. Sounds pretty unheard of, but that's on the forefront of future trends. Additionally, motorcycle helmets, bicycles, luggage, and car parts will become more lightweight and durable. Household products too stand to benefit from these trends with better air purifiers and specialized self-cleaning house paint. So the list of future trends is virtually inexhaustible, and I couldn't begin to cover them all. But as you can see, miniaturization is advancing to new heights in its application across all industries and is revolutionizing our ways of life.